All right, so in reviewing for Summative 4, the first topic it says is using basic trig identities. And it says you can go to worksheet 1B for examples. You can look at worksheet 5, which we have not done, so we could do a couple of those if you wanted. You had an assignment on page 317. And worksheet 9B has some examples of that as well. Okay? Would you like to see some examples? Can I maybe, how about worksheet 5? These are super light. I don't know why. They're not so bad on your screen. On my screen, you can barely read them, but some real basic ones to start off with. What's going on here? Cosine times secant. Yeah, it means cosine times 1 over cosine, right? So we would get what? Is that a cosine squared? No. We just get 1, okay? Cotangent is cosine over sine. And then it says times sine. So what would we get? Just cosine of x. 1 over secant would be 1 divided by 1 over cosine, which would be 1 times cosine over 1, which would be cosine. I think it might even say on your sheet, right, that 1 over secant is cosine. All right, those are pretty basic, probably more basic than what's on the quiz. What could we do to this maybe? If we take out a cosine on the top, what will it say? And then it's still over a cosine, so then we can do what? Divide these guys out. And a 1 minus cosine squared, anybody know what that is? Okay, because on your sheet it says sine squared plus cosine squared equals 1. So a 1 minus a cosine squared would be a sine. Sine squared, we good? I don't choke on my own saliva. All right. That is more like one that would be on the quiz, okay? The first 3 were probably too basic to even make the quiz. Ideas here? Yes, sine squared plus cosine squared is a 1. So then I have 1 plus cotangent squared over cosecant. What's 1 plus cotangent squared? Anything? Oh, it is. 1 plus cotangent squared is just a cosecant squared over a cosecant. It's kind of good that we didn't change everything to sine and cosines, huh? I mean, it would still cancel. It'd just be more steps because one of these is going to cancel one of these, so we're left with a cosecant. Is that all the simplifying ones that there are there? Yeah, this is even out, and that's not on the quiz. Good review, but it's not on the quiz. All right. Is that enough of 5.1 for right now? If you want some more, there's some on 9B. Okay. So there's more practice, and all the answers, remember, are worked out over in the book of keys there. So verifying, it says for verifying, you can go to worksheet 2, which is where we took the notes. You can go to your assignment on page 324, do the ones that were assigned or extra practice. There's extra ones worked out in my book over there. It also says there's a few on worksheet 8 and 9. You want me to do a couple of those maybe? What's 8? Oh, okay. This is 8A. This one would make a good quiz question, I think. Any ideas here? If you change it to sines and cosines, this would say sine over cosine times cosine over sine minus cosine squared. What's the big thing to remember if this is a verify question? Only change one side. Yes, okay, so I'm working with the left side here. What happens to all this? Okay, so I get 1 minus cosine squared. Make sure you're showing all your steps. And then there's a Pythagorean identity that makes that what? Just sine squared, which is equal to this right-hand side. Does yours have a typo here? I feel like I fixed it in... Oh, is it still a typo? I don't know the answer to that. Is this supposed to be a cosecant? So you get cosecant squared minus 1 is cotangent squared. Yeah, I think this one is the typo. It's supposed to say cosecant of x. That one's too easy to even do. You FOIL it together and you get the trade for cotangent squared, okay? Is there anything on here? This is one we haven't done yet. That wouldn't be on the quiz. That's not on the quiz. This one's trickier than what's on the quiz, but we could talk about 5. 6 wouldn't be on the quiz. Oh, 7 would be a good one to talk about. Because I'm thinking you're going to need a common denominator. Let's talk about 7, because I think there's one on the quiz where you need a common denominator, okay? This one's really pretty easy because how could we rewrite this 1 so that it had a common denominator? Just write it as 1 plus cosine of x over 1 plus cosine of x. That's a form of 1, right? And then it says minus sine squared of x over 1 plus cosine of x, okay? Huh. I'm not seeing that that's helping us a whole bunch. Ideas? All of this top is now together, right? I have a couple ideas. Anybody could do this a couple different ways. Okay, if we rearrange this, that was what I was originally thinking too. I think you could trade out a sine squared for a 1 minus cosine squared and you'd get the same thing. But if you just rearrange the top and you wrote 1 minus sine squared plus a cosine, what can you trade that out for? Yeah, there's a Pythagorean identity that says this could trade out for a cosine squared. And you wouldn't have to write as many steps as I'm writing. I'm just trying to make sure that you're following. Okay. There we go. Now can I cancel some things? Okay, factor out a cosine on the top. If you cancel anything that's glued together, I'm just going to write concept error meow next to it because you're killing kitties, okay? Cosine of x plus 1 on the top. And now can we cancel anything? 1 plus cosine and cosine plus 1 is the same thing, right? So we're left with cosine of x, and I hope that's what we were trying to get. Is that what the right-hand side said way back up there? Okay, so that was a good verify review. Is that all of them? Yeah, that one's not on there. Is there more on the back or not? We could do this one. I don't know that this would be on the quiz, but this is on the back of 8. This is 8B. What would happen? Do you just square both of those? You got to FOIL it. I think there's a better way than foiling it even. Look what we're trying to keep one of those on the top, right? If we foil it together, we're not going to have one anymore. Anybody have an idea? We don't want this on the bottom and we're done, do we? What could we trade out that for? 1 minus sine squared? I've done it the other way, and you'll get there eventually. But if we leave the top just written out like this, and we trade the bottom for a 1 minus sine squared, now what could we do to that bottom? Don't cancel out. We have to factor it first, right? Because you can't cancel out. There's a minus in there. So the top is 1 minus sine t over 1 minus sine t. The bottom factors how? It's like a 1 minus u squared, right? Which would be 1 minus u, 1 plus u. So it's 1 minus sine and 1 plus sine. And now one of those would cancel and we'd get the right-hand side. What if you hadn't noticed that? Well, I'm thinking, how would this have foiled together, just as an alternate way to solve this? When you factor that together, you'd get 1 minus 2 sine of t plus sine times sine would be sine squared. Okay. Then what might you have tried? What? Sub for the bottom or the top? So sub this as 1 minus sine squared. I'm thinking eventually you would have had to factor and do something with it anyway. You could what is sine squared equal to? Yeah, I don't think we're going to get anywhere. All right. Let's not spend any more time on that. I think I've done it a different way and gotten there eventually, but what we did here, you ended up factoring and it worked. All right, that's not on the quiz exactly anyway. Prove the identity. This one you would distribute. Want to do one like that? We need to get back to the review though. Tangent is sine over cosine, right? Times cosine plus cosine over sine. If I distribute that, what will I get? Sine over cosine times cosine will be what? And over here, I'll have sine over cosine times cosine over sine. Yeah, this will be 1, and this will be sine, which is what they wanted us to get. That's a pretty easy proof I could put on there, and I would put it as a proof. I would never put that as a simplify question, because I don't know about you. When I got down to that, I would go, am I done? Do you know what I'm saying? I would be kind of confused. So this is a good proof question because you know now you're done. All right. Let's go back to the review worksheet here. So we did some verifying. You feel like you can find some more of those if you need to? Okay. Then we need to do solving trig equations. Okay. We did them. Notes were worksheet 3. And you had an assignment on page 331. There's a whole bunch more of these solving trig equations on worksheet 5. And there's a couple on worksheet 9, but worksheet 5 has on the back some solving trig equations. Is that what it said to do, guys? 14 through 32, it said, right? All right, so 14 says cosine is 1/2. If I put that on the quiz, and this were the directions, these were the directions. Get that right. How would you find the answers? All these need to be in radians. Where's one? Yep, use your unit circle. So where's one where the cosine's 1/2? Anywhere else? Are we done? Yep, it says all values negative infinity to infinity, so we would need this, but that's it, right? We're done? What do we do with a cosecant? Yeah, if you wrote this as 1 over sine equals -2, and then you like cross multiplied and divided, or just flip both sides over will work. You get the sine is -1/2. And where is that true? 7 pi over 6 and 11 pi over 6, yes? And again, plus or minus 2 pi n? Yes, you can just do plus 2 pi n. The plus or minus is just me trying to remind myself that there's positive and negative. Okay, this one, tangent is -√3/3. What ordered pair am I looking for there? √3 here and 1 here, is that what I heard you say? Because 1 over √3, y over x would be √3/3, we good? But I need either this to be negative or the back one to be negative, right? Because it was a negative. All right, so that ordered pair happens at 5 pi over 6 and 11 pi over 6. Do I really need both of those? I'm fine with you putting down both of them, but tangent has a period of pi, right? Oh, that's supposed to say plus pi n. I don't know what that thing is. It's out of control pi. And those are straight across from each other, right? If you put both of those and put plus or minus 2 pi n, I wouldn't count it wrong. Okay. I'd rather you remember that tangent repeats every pi, even if you put both of them. But if you put 2 pi n, you have to have both of them because, anyway, I'm getting all. Yes, because if you go pi n after 5 pi over 6, you land at 11 pi over 6, so it's covered. Yep. All right, here's a couple more good ones. What do we want to do here? Let's see, if we subtract 4 sine t over here, get -√3 equals -2 sine t. Then if we divide both sides by -2, what will we have? Positive, right? Like that. Why is this any different than the ones we were just doing? Yeah. What does that mean? You give me your unit circle answers and you're done. No plus or minus anything. The only answers that fall between 0 and 2 pi are pi over 3 and 2 pi over 3, right? Are we okay? Because it's sine, not cosine, right? All right, what about this? Oh, that looks ugly. 12 equals -4 cosine of t, divide by -4 and hope that reduces, yes? Because this should have reduced to 2 square roots of 3. So that was a really disgusting disguise for negative square root of 3 over 2, right? Okay, and cosine is negative square root of 3 over 2 at, and, okay, good. It's possible that there's one tomorrow where you have to factor like this, like take out a sign, 25. Was that what you would know to do? What'll this say after you factor out a sign? 1 plus 2 cosine. And then we need to say this times this equals 0. So either this is equal to 0 or this is equal to 0, which would make the cosine negative 1/2. We're doing 0 to 2 pi. So the sine is 0 where? 0, pi, 2 pi. Do we include 2 pi? No, because it had a soft parenthesis here. Cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. So there's our 4 solutions. Don't need any plus or minuses. We good? Go ahead. What? It's already factored. So you just need to set this equal to 0 or that one equal to 0. Is that okay? What about one like 27? Can you factor that? I don't want to take time to solve the whole thing, but could you tell me how that might factor? Because this is a factoring one again. To get 2 sine squared, you need what? 2 sine times another sine. To get a 1 back here, you need a 1 and a 1. Now, this is where people get all messed up. You got to practice FOIL this back together, right? So this is 2 sine x and this is 1 sine x. One of them's got to be negative. If I want a negative in the middle, if you're not sure, try it. But I think that's right, because you get a negative 2 plus 1, which will give you a negative 1 in the middle, right? So then you're saying the sine is negative 1/2, or the sine is 1. And I'm going to stop there. We good? All right. The other thing that you have on that section, you have a solve by graphing. Was there any solve by graphing on that worksheet? Worksheet 5, there's no solve by graphing? Oh, here. 21. This is 5b still, okay? How do you solve this question? In radians? Yeah. It says use your calculator. So you go to y equals and you type in 4 sine x, or you could do sine x equals 3/4. Do you want to leave it like it is or move it around? Leave it like it is? Okay. 4 sine x, close parenthesis, and then a -3. Okay. I'm going to tell you that the one on the quiz says this. Okay. You don't need the plus or minus. So when it says that, I would go to the window and just set up my window as 0 to 2 pi for x. And then I would graph, and the way we've typed it in the calculator, what are you looking for? Yeah, where it hits 0, because we typed this. So you need this 0 and this 0. Now, I would probably be really lazy and put a 0 in one of my y equals, and then I can use intersection, because otherwise I got to find the 0 thing, and we need a left and right intercept. Remember? I like to cheat and just say find the intersection point. So I got 2.294. Did it say 3 decimal places or 4 up there? 3, right? And then if I do the other one, I could do it by 0 if you want me to remind you. You have to go a little bit to the left of it, a little bit to the right of it. Oh, and I'm on the wrong equation. If I want to find this one over here, I could say it's somewhere between 0 and 1, maybe. I have no clue. All right. Left bound, go to the left, enter, go to the right. This is why I don't ever use this. If I can avoid it. Did you get 0.484? 848? I just read it wrong. Okay. Guys, if it said all solutions, you'd need a plus or minus 2 pi n on the back, because that's how often sine would repeat. Okay. But the one on the quiz doesn't say that, so you would just need to find the 2 decimals. Are we good? Okay, so there's plenty more practice on worksheet 5, and all the worked out answers for worksheet 5 are in the binder. All right, that takes me, unless someone has a question, back here to inverses on the review sheet. Okay, you don't get to use your colored unit circle tomorrow, guys. On your yellow unit circle that I'm going to give you, you have this unit circle, but you also have this at the bottom of the page, which is on your pink sheet. This tells you, is everybody looking? This tells you when you are doing inverse sine, you need to answer, which 2 quadrants is that? Quadrants 1 and 4, and when you're down in 4, you need to call it negative something, right? And the same is true for tangent. 1 and 4, and call it negative something. If you're doing an inverse cosine question, it's in quadrants 1 and 2, and you don't have to renumber anything. Okay, so let's go through these real quick. Where's the arc sine negative 1/2? Using your pink one now. I can never look in quadrant 3. That's the thing, okay, guys? Don't ever look in quadrant 3 for anything, and you'll be good. The place that sine is negative is down at 11 pi over 6, but I can't call it that. Negative pi over 6. We're good? I'd rather you didn't, because I'm going to collect them back. Okay? If you do accidentally, or you need to, and it will help you, Hunter, I'm fine with that. Just show me and then I'll throw it out, because I have plenty of extras. Okay, guys? If you need to write on it tomorrow to renumber it yourself, that's okay. Just let me know so I throw it out. Arctangent, negative square root 3 over 3. Quadrant 4, right? But I'm looking for this. Like that. Is that right, guys? Tangent, yeah. So it's, again, the same spot, isn't it? Negative pi over 6 again. Okay, where's the cosine 0? Pi over 2, we good? Tangent, negative 1. Always get weird answers here. I'm looking for this ordered pair, guys, right? So it's down at 7 pi over 4, except we have to call it negative pi over 4. You gonna get that right tomorrow? Okay, this one went well for some of you, and some of you were totally confused last time. Where's the sine negative square root of 2 over 2? Negative pi over 4. Okay? Then what is the cosine at that spot? Positive square root of 2 over 2. We okay? Inside out. All right, what's going on these two questions? You have to draw and you have to figure out which quadrants. Okay, arctangent is negative or inverse tangent is negative, so I know I'm in quadrant 4. Okay, where do I put the 4 and the 3? Opposite over adjacent or y over x, which one is negative? Okay, and then I do Pythagorean theorem and get a nice 5 for this one. What's the sign? Negative 4 over 5. You guys got a question, Florta? Did I do something wrong or do a question on that one? Okay. We're good? All right, guys. Arc sign is positive. Tells me I'm in quadrant 1. Opposite over hypotenuse. I do Pythagorean theorem. 11 squared minus 3 squared, because I'm looking for a leg, is going to be 112. Is that right? Square root of 112, which is divisible by 4 at least. What is that? Oh, 16 goes in there then. Yes, it means you're looking for an angle. No. That's a great question because a lot of you did that on the quiz, guys. Inverse sine and arc sine don't flip anything over. What flips things over? Cosecant and secant. Okay. Inverse sine means you're looking for an angle. Okay. So this is still opposite over hypotenuse. So 16 went in there how many times?
7.
So it was 4 square root of 7 because it was 16 times 7. All right. I don't need a negative. And cosine would be adjacent over hypotenuse. We good? Okay. This is the one that killed some of you. A lot of you got it right the first time we did it. But arc cosine with a letter, I always said you can use quadrant 1, okay? Cosine is A. What else? I can't solve that. But I can put A over 1, right? I don't know. You might get a fraction on the quiz tomorrow, but if it had this, it would be A over 1. Now, how do I find this side? Here we did 11 squared minus 3 squared, right? So this is going to be 1 squared, which is 1, minus A squared, square rooted, and you can't simplify. All right, now it wants the tangent. Opposite over adjacent. Okay? There's a whole remediation sheet on inverses over there you can practice on. All right. Then the rest of the quiz is law of sines and cosines stuff. Okay? What do you want me to go over? One where you do cosines backwards, one where you find area, one where you find, I don't know. What? One where you find 2 answers for a law of sines? Sure. There's 2 possible solutions when you have this guy, remember? 2 sides and an angle not in between. This is AC, an angle B in between. So this is a law of cosines question. Because it's gonna set up 29.3, 24.8, and a 97.3 and find this side over here. She'll do B squared equals. Okay. I'm just looking for the right kind. One of these looks good. K, H, P. If I have a 154 here, 22 over here, and 10 here. Anybody see a problem already? Anybody know what's going to happen? This is going to give you a domain error when you type it in. Because can you have a shorter side across from 154? No, that one's going to be a no solution. Which makes me think this one is more than one solution. Okay. A, B, C, 63, 35, and 34. All right. Well, it says find angle B, but can I find angle B right away? No, I got to find angle C. So I'm going to do angle sine of C is across from 35 in the same way sine of 63 degrees is across from 34. Then I'm going to type sine of 63 times 35 divided by 34. Get a decimal. What mode do I want to be in? Degrees. And I did put a warning on the quiz again, but doesn't mean you'll all read it because somehow directions are ignored so easily. So I get a decimal, and then I have to do inverse sine, right? And any time I do inverse sine on my calculator, I have to do the supplement of that because the sine graph looks like this, and it hits that 0.917 value twice before 180. Okay, so if I do 180 minus this answer, I get 113.5. Okay, can I have a 63 and 113.5? I think so, right? Okay, so if this is angle C, and I already know angle A is 63 for sure, then to find angle B, I need to subtract both of those from 180 or both of those from 180. So, it's faster for me to use this. Angle B could be 50.5. Did someone get that? Or a little 3.5, which is possible. Everybody okay? What else do you need to see? Yes. Can I do the applications? Click. Huh? Number 9? Okay. Yeah. This one says, and I can just set this one up for you. It says a pilot flies in a straight path for an hour and 30 minutes, which is 1.5 hours, right? Then makes a course correction heading 10 degrees to the right of original path. Flies 2 hours in a new direction. If she maintains a constant speed of 680 miles per hour. Okay, I don't know that the one on the quiz is this complicated, but if she went 680 for 1.5 hours, rate times time would give you a distance. That distance would be 1020. Anybody got that one? Did I do that right? Okay. Then she turns 10 degrees to the right of her original path. You think like that? This is why I would have drawn a picture for you if I was going to give you this question, I think, because it's a little confusing. And then she goes for what? 2 hours. So 680 times 2 is what? 1360? Did I do that right? Okay. How far is she from where she started? I'm thinking we need this angle, which is 180 minus 10, to be 170. So now I have this triangle that I'm trying to find this side of over here. I'm just going to redraw it. 10, 20, 170 degrees, and 1360. You'd have x squared equals, and you'd type super duper careful, right? I'd do this one twice for sure. Make sure I didn't type something wrong. Make sure I'm in degrees. What do I got to remember at the end? My answer is going to be big, but it should be somewhere in line with these. I got 2379. Did anybody, because I got a square root at the end, did anybody else get that? 0.4. I hope I'm close. Yeah. The longest third side would be if I added those together. That would be 1380, 2380. So it has to be less than 2380. I got 2379, but it's a 170 degree angle, so it should be pretty close. All right, seems reasonable. There is a question like this. Does anybody know what you're going to have to do to find this height? You're going to have to find this first, and I may have given you that hint on the quiz, okay? What are we going to have to do, though, to find that? We need to know a whole bunch of angles. 180 minus 24 is 156. Did I do that right? 180 minus 156 and 22 leaves a little 2-degree angle up here. So now how can I find x? 2 degrees is across from 200 in the same way that the sine of 22 is across from x. (200) sine of 22, close parenthesis, divided by sine of 2. And did I just do the last question wrong? I was in radians. Did someone else get a different answer here? This should be 2371. Okay. Yeah, wouldn't have noticed that. Thanks. Except this question, I got a negative answer. Then I noticed that maybe I was in the wrong mode. Yeah, I know, but I was using a different calculator. I was using, did someone get an answer for this? 2146.8? Okay. So now how am I going to find h? Well, I'm just going to be lazy and use SOHCAHTOA because it's a right triangle here. See this? So from this angle over here, the sine of 24 degrees is just opposite over hypotenuse. I got 873. The mountain is 873.1 or something feet tall. Did anyone get that? Okay. Yes. Find what?
The other height.
Yes, you could have, and then you would have had to use the giant triangle. It still should be about 873. Yep. All right. I do want to talk quickly. Did someone ask me to do a different one? This one, number 3? How do we find E? 21 squared, 26 squared plus 28 squared minus 2 times 26 times 28 times the cosine of E. 21 squared minus 26 squared minus 28 squared. All over negative 2 times 26 times 28. And then inverse cosine. Okay. Answer key will be online, or it's in the book over there. Quiz tomorrow. We good?